Oh no, we landed in the middle of the mountains. How will we reach the bottom and go home? Today we'll be exploring differentiation and gradient descent, the two ways to reach the minimum. Plotting the mountains, a 2D graph is what we would see. We have to locate the minimums. These local minimums are not good enough because to go home we must find the absolute minimum. Let's say the equation is y is equal to 2x plus 4. To find the minimum, we must start by finding the slope. Because at every minimum and maximum of any equation, the slope is 0. To find the minimums, we must find the points where the slope is 0. This is where differentiation, or slope, comes in. Slope is a change in y over the change in x. On a curve, the slope is different in every point. Slope is now calculated through infinitely small deltas. That is differentiation. There are a few basic rules of differentiation. Applying this to our equation, we get 4x, since both terms of the equation can be differentiated through rule number 1. We know that at x is equal to 0, we have a slope of 0, but this could be a minimum, maximum, or neither. And there are two ways to find this out. Brute force or checking the slopes on both sides. For brute force, we get an xy table and find below, at, and above, and this shows a minimum. For checking the slopes on both sides, we create a sign chart, and below, at, and above, and this also shows the minimum. The idea of finding the absolute minimum is brought to gradient descent. Gradient descent is a method used by machines to perform human tasks with minimum error. Error is usually a multidimensional and complex function, and because it's so complex, we can't use this earlier approach. Instead, we have to use gradient descent. Let's play a game. We're dropped on an island, and we know there's gold on this island. We're given a gold detector. This gold detector beeps loudly when we're close to the gold. Our strategy, we're going to move in a circle with our gold detector, and wherever it beeps the loudest, we're going to move in that direction. This is what we observe. Take a random point and follow the beeps, and the gold is here. This is how gradient descent works. Now, in the rare case you're stuck in the mountain, you know what to do.